Hello, welcome everyone. My name is Mohammad Mousavi. I'm a professor of software engineering at the University of Leicester, and what I will do today is to give you an overview of our research in trust in autonomous systems at the University of Leicester. So our mission statement is to apply rigorous analysis techniques to ensure safety and to establish trust in autonomous systems. Of course, I will explain the words that I use in this mission statement, but in order to achieve this mission, we collaborate with many different companies, some of which you see on this slide. We also engage with the public in order to inform them about trust in autonomous systems through many different channels. So you see the logos of some of the media where we regularly appear and we explain to the public about this issue of trust in autonomous systems. We also collaborate with lots of learned societies such as the Royal Society, London Mathematical Society, to explain how to achieve trust in autonomous systems. So what does trust mean? Trust basically means that you believe that the autonomous systems, or any system or any person for that matter, is not going to harm you and is going to be helpful in uncertain and challenging environments. So if you're dealing with a robot and you believe that the robot is not going to harm you and is going to be helpful in difficult situations, then you have trust in that robot. How do we achieve trust? One means to achieve trust is through technical transparency. If you know how the robot has been built, if the designers have been explained properly to you, that's one way of achieving trust. Another way of achieving trust is to provide explanation for the behavior of the system. So once the system makes a particular move, if the system can explain to you why it made that move, then you are going to trust the system. For example, if you're sitting in an autonomous vehicle and it takes a very strange turn and it does not provide any explanation why it took that turn, then you may mistrust the system. However, if it tells you that this was because of a traffic jam ahead or to avoid an obstacle, then you are going to gain trust in the system back again. If there is enough evidence that the system is safe and secure, you're going to trust it further. And also, if the system interacts with you in meaningful and trustworthy ways, for example, by providing human-like explanations, then you're going to trust it further as well. So a couple of projects that we have performed in this direction. One is about connected platoons. Platoons are convoys of vehicles, be it passenger cars or lorries, of which the lead vehicle is human-driven, so there is a driver in charge of the lead vehicle, and the following vehicles follow that without a human driver, so they follow the lead car autonomously. And we have done all sorts of testing in order to reveal any possible safety issues in platoons, and actually we have been very successful in pointing out design issues in connected platoons. We have examined the communication protocols that keep vehicles informed about each other, and we have shown that under certain parameters that those could pose safety risks, and then came up with suggestions how to improve those behavior in connected platoons. This is done in collaboration with colleagues in Sweden and in the Netherlands, and also we have built an extensive toolbox together with colleagues in Brazil. Another aspect of trust is about environmental impact of autonomous systems. For example, consider autonomous vehicles or automated functions of vehicles. We are interested to know whether they are having an environmental impact, adverse environmental impact or not. And for this purpose, we collaborated with our colleagues in Germany, in Aachen, in order to analyze the NOx emission of diesel cars. The goal of this research was, and still is, to reveal the cheating behavior of car manufacturers, and also to provide guidelines for autonomous vehicle designer to design controllers that would lead to less environmental impact for autonomous vehicles. This is a very interesting ongoing research where we are examining actual cars and we are looking at their emission behavior, and we use various different techniques, including machine learning, in order to find out whether we can reveal cheating behavior in such cars. This has been published this year in a conference, and this is an ongoing research that involves very interesting experimentation with actual cars. We have different expertise contributing to this area. including model-based systems engineering. We have a lot of expertise in testing, validation, and verification. We have expertise in machine learning. We collaborate with a very nice group of colleagues in human-computer interaction, and also we work in big data analytics. This website, driverless.github.io, provides an overview of our public engagement activities. And we apply our research to various domains, including autonomous vehicles in the automotive domain, in robotics, and also in drones. As an example of our success, we have just won a very big research grant from the funding organization of the UK, UKRI, to lead a large group of 17 world-leading scientists and hire 9 postdoctoral researchers in order to look at trustworthy autonomous systems and establish their verifiability, which is an important aspect of trust. If you're interested to learn more about our project, look at verifiability.org, and there you'll see some more information about our vision, our team, and our early results. The team that has been involved in this large project involved, of course, our own group on validation and verification, but also colleagues from human-computer interaction, also colleagues from mathematics. So you see lots of different expertise come together in order to establish trust in autonomous systems. Thank you very much for having listened. If you have any questions, please do not hesitate to drop me a line at mm789@le.ac.uk. Thank you very much.